All right, welcome everyone. The time is 3:30. We appreciate you choosing to spend some of your afternoon with us. Um, our focus this afternoon is on the graphing calculator that we embed into our NCTest testing application. We have an excellent presenter with us today from Desmos. Our focus today is for grades 8 through high school. My name is Beth Nash. I am a test measurement specialist here at the North Carolina Department of Public Instruction. My purview is state testing. So whether you take our NC check-ins or our NC check-ins 2.0 or our EOGs or our EOCs, those are all what I do day in and day out. So you have my contact information here. We'll make sure we share it again before we leave, and you'll receive it in an email as a follow-up. Please reach out if you ever do have questions. A couple quick notes before we get to today's main event. Everyone is muted due to the size of the call. I know it looks like you're the only one in here. That's just a weird little setting that WebEx does to trick us. We have just over 300 people scheduled to join us this afternoon. Today's webinar will be recorded and it will be sent out to anyone who registered. We know sometimes last minute things pop up and folks register and have every intention of attending, and then life happens. So anyone who registered will receive a follow-up email. The follow-up email will come from North Carolina Public Schools. So you may have to take a peek in your filtered folder, your other folder, but it will have the recording of today's call and also all of the links so that you can click on them. Once I stop talking, I will share these links in the chat. Our feature calculator is the graphing calculator, and we have an agenda and a slide deck to share with you. And it's important to note that NCDPI is not offering any CEUs for today's webinar, and that's for either joining live or for watching it after the fact. Again, because we are expecting quite a few folks this afternoon, we ask for your assistance in communication. We're going to ask that you use the Q&A feature if you have any content-related questions that you would like to get answered today. And so those could be, perhaps you need Nolan to go back and show you something else, or maybe you have a question, does Desmos do X, Y, or Z? And Nolan is an expert. He can help us with those things. We will be stopping periodically to address questions. Anything that's a super easy question that I will, the great thing about Q&A is it will let me select the question and then type an answer, and it keeps it nice and organized. So I will try to respond to what I can in the Q&A, and the ones that I can't, we will stop periodically and call out and try to address as many questions as we can live on the call. We're going to ask that you please reserve the chat feature for technical support, and then I will also drop links in there for you to click on if you have multiple screens going today. If you have any technical difficulties today, if you're struggling with sound, if the call drops, if you have a friend who would like to join the webinar and they can't figure out how to get in, we do have Stephanie Boyd with us today, and Stephanie is our tech guru. If you send a private chat to Stephanie, she can help to get you connected and help with any of those tech issues you're experiencing. But content-related questions, please use the Q&A for that. Before we get to Desmos, we do have a couple quick notes. We know that our primary focus today is classroom teachers, and so we have a few updates that we are trying to get out in as many different platforms as we can to make sure teachers know so that they can prepare their students. If you've been in North Carolina for a while, you're familiar with NCTest. This is the link to take you there. We are excited this year to be able to have a couple enhancements to our online testing system. And one of those is the ability for students to enter mixed numbers. In years past, any of our items that were numeric entry, we asked that students enter them as improper fractions. And we are so excited this year to have the opportunity for kids to enter mixed numbers instead. This is available immediately for all online testing, for all grade levels, and for any of our products. So check-ins, check-ins 2.0, EOGs, EOCs, Extend 1. This is a screen grab of NCTest, and it's showing you how, of course, a very simple question, what is 1 plus 1/2? But it shows you that not only has the text underneath the box been updated to instruct kids how to enter a mixed number, but you also have the ability to type it in. In the past, you'll recall we would have asked kids to put in like 1.5 or 3/2 or another equivalent form. Those are still fine to put in. If kids are used to converting to improper fractions, that's fine. But we are excited, based on feedback from teachers across the state, to offer this enhancement this year for kids to be able to enter mixed numbers. Also, a little bonus note, if you click on the highlighter, this year we have expanded from one color, yellow, to also include blue and pink. So if you are a teacher who teaches your kids to color code, they will have that ability on their state summative testing. So also, when I send the follow-up email late today, I will include a screen grab of this slide so that you can share it with others. But we hope you'll help us get the word out. And with that, I am going to stop talking. I'm going to send it over to Nolan. And Nolan, I will be manning the questions, but otherwise, sir, you now have presenting privileges, sir.
All right. Thank you so much, Beth. Thanks for hosting today. And thank you to all those logging in or even watching the recording at a later date. But thanks for taking time out to learn some more about Desmos. I know you're going to benefit, and also, more importantly, your students are going to benefit from hopefully what you see today. My name is Nolan Doyle, and I am a classroom teacher up in Virginia, just outside of Richmond, so not too far from you all. And I began using Desmos in 2012, so I've been using it for quite a while. Also Desmos teaching fellow and certified presenter. So what I hope to bring today is experiences from both those things, both my time in the classroom, as well as my time working alongside Desmos as a fellow and presenter. A little about Desmos as well. Desmos believes that all students are brilliant, and that it's our job as teachers to tap into that brilliance to help students learn math. So Desmos Studio wants to build a world where students' access to the power and beauty of math doesn't depend on their place of birth, race, ethnicity, gender, or any other aspect of their identity. I don't like reading slides, but I just love that statement so much. I just like that it talks about not just accessibility, but what are we giving to our students? It's the beauty of math. It's all about math and the power that's there. So it's not about the technology. The math needs to lead, and the technology needs to follow and support that. It's not just about button pushing or getting answers. We're going to use these tools today to help students really explore the mathematics on their own. And when we talk about accessibility, one of the big things is that these calculators and the activities that you're going to see today as we go into Desmos Classroom, those are all free. Those are all free to you and your students to use. The Desmos company is also guided by some specific equity principles and pedagogical philosophy, and we invite you to check out our website to read more and learn more about those. Today's agenda, that bit.ly that's been showing up and Beth has thrown in the chat, that shows our agenda as well as a ton of resources I'm going to leave you with. So we'll wrap up the intros and welcome in just a minute. And then we'll spend a little bit of time looking at, okay, what does the Desmos graphing calculator look like specific to North Carolina? What are the differences between the standard calculator that is the public facing one for everyone to use? And then my favorite part is we get into the teaching with Desmos. And I'll show you a little bit of where you can go to maybe start building your own activities. But our main focus is really that third bullet today is what does it look like instructionally with Desmos? What does it look like instructionally using the calculator, as well as maybe some of the activities that are housed at teacher.desmos.com. We'll go over some next steps and have some times for Q&A. Really, the Q&A has been working well with the elementary and middle, kind of checking in as we go. So pop those questions in, and Beth will answer the ones she can, and then we'll stop periodically to make sure we address the other ones. What the learning goal is not is to become an expert, right? So we have some limited time. So what today is going to be is really a what can, not how to. With the limited amount of time, I really want to showcase what Desmos and those tools look like in the classroom and really inspire you to then dig back into the how-to on your own or with the support of your colleagues, with the support of the resources I'm going to share with you. the help.desmos.com. I'll show you that multiple times, is a great place to go. And there's also a great professional development page by Desmos where there are tons of free videos and webinars that you can dig into some more. So we're going to go ahead and jump into the Desmos tools. So when I go to desmos.com, at the top of the page, you'll see kind of 3 drop-down menus, and on the left are all the different calculator tools that are there for you. We're not going to go to the standard graphing calculator. We're going to go under resources and assessments to find the North Carolina version. And so when I go into resources and assessments, I'm going to scroll down to our map and find North Carolina. And so here I have the specific versions that are slightly different for North Carolina. Each state gets to kind of tweak and add or take away different features for the calculators. And these are the North Carolina ones, as well as this PDF that gives you a nice breakdown of what those differences are. So I'm going to go through in just a second and show you these differences. It looks like a lot, but it's actually really kind of cleaning it up and taking away some extra features that really, for the most part, the students are not going to be using anyways, so it won't be a distraction to them. When I go back here, when I click on the actual graphing calculator, this is the North Carolina one. I know it's the North Carolina one because it's green at the top, and it says NCTest version. If I were to go to, I'm going to pull up also just the normal standard calculator. You can see it's black at the top. I'm signed in, so I can be saving graphs, things like that, that I won't be able to do in the testing version. Do want to note that you can go directly to all of these things from our agenda. I put in links, the standard graphing calculator there, and then I highlighted, this will take you to that PDF I just pulled up. And the second highlighted link will take you to the North Carolina version, as well as some more resources as you're exploring. So one of the differences, the first one was that images and folders are not available. So when I hit this plus sign in the regular calculator, I can organize things with folders. I can also bring images into the graph and also make notes. Those will not be options, really just going back and forth between the expression list, which is what it defaults to for the calculations and for the graphs. And then you could also add a table to plot points. So students have their expressions and then the table as well. The keypad is a little bit different. So I've been kind of using just my keyboard to enter in different things and type them in, but we can pull up the on-screen keypad, and we've got our basic numbers and operations here. We have over down here is the alphabetical keypad. And so this is alphabetical on the North Carolina version. In the standard one, it's your QWERTY keyboard one. So that's one difference. So you want to have your students getting used to that probably here. Also, what's nice is if you hit this wrench up here, I'm a geometry teacher, so this is helpful for me. We have this in Virginia too, where the default is going to be degrees. So as they're doing their calculations, sine of 30, it's defaulting to degrees, whereas the standard calculator defaults to radians, so you would have to switch or toggle to degrees. This is probably an important one to definitely be aware of. In the PDF, it says plot single variable implicit equations. So that just means something like x plus 5 equals 7. This will basically is going to graph, right, x equals 2 here, that vertical line, x equals 2. When I go to the North Carolina version, it will not graph that, and you'll get a message that that is disabled in this version. So that's one to definitely make note of if you've been using the standard calculator. The next one is it's going to force log mode regression. So all that means is when you do a exponential or a log regression that I have pulled up here with my table, you have an option to run that regression in log mode or not. And in the testing calculator, it's just going to automatically do it in log mode. And so log mode is what a lot of the handheld calculators use automatically, and Desmos has the option. You can read more about log mode and what that means if you click on that question mark, or go to the help.desmos.com. I thought I had it up here, but I don't, to learn more about that. Another one is it talks about actions. So actions is kind of a, I would say more of a higher level feature or advanced feature here, Desmos calls that. And so you can learn more about that at the Desmos Help Center. But that's going to be something, and it's kind of a newer feature that maybe you as a creator of a graph would be using for students to interact with. It's not something that students would be using anyways, but so those actions are not available. Last couple things, when we go to the standard calculator, the menus here of different functions, you can see there's quite a few functions, and some of those have been removed when you look at the testing one. Okay, so the ones that have been removed are listed here or disabled right there for you. So most of those advanced trig functions, advanced stats, and geometry wouldn't be ones they're using, or the geometry ones, right? They don't want to be able to use those because we want to find distance and midpoint in different ways. All right, so there's a rundown of the differences. I'm gonna maybe stop here and check in with Beth to see if there's anything that we can answer at this point as far as finding the testing version and some of those differences that you see.
So far things look good. Steph and I have been able to do the questions we've that have popped up. I will mention one thing. I think it's great the way Nolan has showed you guys the differences between the two. The reason that that North Carolina has chosen to make some of those changes is to align us with handheld calculators. So it's really an equity issue. While we are moving towards online testing, there are some students that will never be able to access an online test for perhaps they have a 504 plan, or they have an IEP that they would need to have a paper copy. And so in those instances, students are using handheld calculators, and it's to align us so that there's not a fairness issue. As I've been speaking, Nolan, we did have, could you show again from the main Desmos site how to get to the North Carolina version, please?
Sure. So when you get to Desmos, the best way is go to resources and assessments, and then scroll down to your map. And there's the PDF, and there's the graphing calculator link there. You can also, like I said, I put these in the agenda. So this would take you to the graphing calculator, and this would take you to that PDF. So you can have those, bookmark them, whatever you need to save those. All right, so I want to kind of change gears a little bit, focus less on just testing, but using Desmos instructionally. So, when I think about all those states that are starting to add Desmos to their tests, it's not necessarily because it's the best tool for taking a test. I believe it's the best tool for students to learn and understand math on a deeper level. So, and if we're learning math with that tool, why not make that tool available to the students as they're being assessed on what they've learned? So, in order to kind of use it effectively instructionally, I always like to think about the verbs. What are the things that we're able to get students doing? And not me as the teacher, but really the students doing these things, making predictions, inviting their informal ideas before formal ideas, have them noticing patterns, maybe starting to describe those patterns and generalizing them. Also identifying and building structure. So we can do that with our students and facilitate that. And also what I love is connecting representations. So we don't want the functionality here to avoid algebraic methods, right? We want to use these tools kind of as an exploration tool as students are learning different things. So just a quick kind of demo of a few ways that I would use this instructionally. I know the first thing, I'm gonna go ahead and hit this display under the wrench and make it a little bit easier for you all to see. The first thing I saw with Desmos that really sold me on it back in 2012, can't believe it's been that long, was sliders. So, right, like I can graph a line in slope-intercept form, right? And so it will just graph y equals 2x plus 4. But I can change these to variables. And Desmos is saying, wait a second, too many variables. We need to define m and b. So we can define them with sliders. So it prompts me to add these sliders. I'm not doing anything magical to get those things to pop up. And as soon as I do that, it's now assigning a value and I can quickly assign different values. So all of a sudden, that static graph becomes dynamic. So I've got this really cool visual of the algebraic representation right next to the graphical representation. I can go hands-free, excuse me. And we've got this dynamic graph animated that I could just throw up. And I love this. I created this in just a few seconds. And I've got a really powerful opener for my students of, okay, what do you notice? What do you wonder? What do you see? And students can just start giving me their informal observations of, what's changing. Well, the direction hopefully starts to come out, what my students might see, and the steepness. And we can start moving towards that more formal definition of slope and what slope tells us about the line, where it falls in this form of the equation. Right, we can do the same thing with B. What do you notice? What do you see? Right, so some students see it going up and down. Some students see it going left and right. Sometimes if I change the steepness, it looks a little bit different to students. But we can then also pause at any point and just quickly click, right? Like, so some calculators, you gotta do all this button pushing, menu navigating to get these key points. And Desmos is just like, just come over here and click. There they are. So we can focus our attention on the significance of those values and those numbers instead of in those points, instead of, how do we actually get them? And so we can start connecting to making that connection of, oh, those numbers are the same. And because of the slides, because of the technology, I can get a bunch of examples, right? And start to see those patterns and connections. All right, so that number is going to tell us where it crosses that line, that y-axis. So sliders are really, really powerful in my view of getting students to discover these things instead of me just telling them. And as an Algebra 2 teacher, I love doing stuff like this with some more functions, right? We can do with any type of functions, I can use H and K here, and I can get my students to start thinking about what's happening, right? What's going on here? What do you notice? And then we can get into the why, what's going on, and really break it down and formalize it and start to generalize in our notes. Also, my geometry folks, right? We can look at our circle too, right? So we've got kind of, I remember Michael Fenton at Desmos said, we got like this mathematical sandbox for students to play around with. We can create these tools where students can play around and make some discoveries on their own. Another really cool tool is lists. So with lists, I can still do some variable. I'm going to use A this time. And I need to assign, again, some value. I need to define A. But instead of defining it with the slider, I'm going to use a list. And so I could start my list and just put -10, right? I could put another value, -9. I could put more values and keep going all the way to 10. And so as I put these in, right, the calculator is assigning each of these values from the list into that equation. And so we've got 21 lines here with 21 different slopes. And so one way to really utilize this is I kind of jumped the gun. I showed what it looked like, right? So what I might do is turn that off and just get students to predict what that's going to look like. Do a think, pair, share. What do you think this is going to look like when we go through there? And then I could switch it up and change this. Instead of putting A there, I can put A there. So you can kind of follow along now. We saw the first one, but kind of think to yourself, what would this graph now if A is in that spot of the equation? think about when I get my students, they're going to start talking to each other in that think, pair, share. And I love it because they're going to start using their hands. They're going to start moving around to try and communicate to their partner what this is going to look like. So we can talk about how many lines they're going to be, what's going to be the same about the lines, what's going to be different about the lines, right? Getting students to talk about that same slope, right? Different y-intercepts. What does that mean about the lines? And maybe start talking about parallel as well. And then we can reveal it, that big reveal. So students are engaged, they're talking, they're discussing, they're predicting, and they're also kind of committed to it, and they've got some investment in it because they want to see if their prediction really works out. Kind of along those same lines, I'm gonna do another one. But instead of turning it off, we're just gonna put this little mark so it doesn't show up. So this is one you can kind of follow along here. Think about what this one's gonna look like. So again, I'll put this up. I've got my list. I'm gonna ask my students, hey, what, when I take this mark away, what is gonna be graphed? And there's the big reveal. And we can talk about how many circles are here. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10, there's not 21. So we can talk about why. We can talk about those negative values, right? We're not gonna have a negative radius. So we can talk about what this meaningful value is here, A, what it represents or what the connection is. 0 isn't gonna be graphed. A circle with a 0 radius is not gonna be graphed. We can also talk about why they're not spaced evenly and what we could do to get back to be spaced evenly. So this is a really powerful conversation of, hey, this is not just directly the radius, it's the radius squared. So if we put a squared, now we're getting those radiuses of 10, 9, 8, and so on. Whereas before, it was the square root of 10, square root of 9, square root of 8. So a really powerful visual to go over. I know my students always mix that up of they think this is directly the radius. They forget that it's the radius squared. So that relationship is really, really important. This gives a powerful way to look at it. All right, so we've seen some really cool visuals and some dynamic visuals. Another thing I like to do is kind of use the technology when I introduce it to kind of get students to think about, well, what's the calculator doing? And then we use the calculator and technology to verify it and then take it away. And they need to be able to do it by hand, but they could also bring it back to verify their answers and check their answers. So it's definitely not replacing what students might do algebraically or know. So, but it's helping them discover it and also then check and get feedback of what they're doing. So function notation, if I was introducing that, I might throw up just instead of y equals, say, you know what, we're going to start writing the function this way. And we can also start typing in things like this, f of 2. Or maybe I'm just going to start with f of 1, f of 2, f of 3, f of 4, and so on. And just invite students to notice the patterns. What do you notice? Right? What do you wonder? Yeah, so hopefully they'll make some connections when the numbers are going up by 1. Oh, this number's always 5 more. Right? And so when they start noticing that pattern of this is always 5 more, well, what's this equation say? Whatever x is, the y or the output is going to be 5 more. And we start talking about inputs and outputs, right? So this notation allows us to see those two things. And if we're talking about inputs and outputs, we're talking about x's and y's. Well, all of a sudden, let's put these together. How can we put together an x and a y? Well, we can plot them as a coordinate pair, 1 and 6, 2 and 7, 3 and 9. And again, I love, whoops, not 3 and 9, 3 and 8. It's been a long day. There we go. And we can see everything on one screen. We don't have to go back and forth between different menus, different screens, right, to see the equation, to see the numerical values, to see the points on the graph. And we can start to really make those connections between all those representations. I love it. Okay, and that new notation maybe isn't as intimidating as we build it up through these visuals. right? And you can also get students to make their own predictions. So give me a number that goes here. Okay, what is the result going to be? Have them make that prediction before you enter it in. Another thing I like with verifying algebraic procedures or understanding some big concepts on a deeper level, there's times in my Algebra 2 class where we're doing some work and we need to review some basic Algebra 1 properties. So there might be a problem where something like this comes up and some students are telling me it's this. Some students are telling me it's this, and we want to have a debate as a class. Okay, which one is it? All right, and as we do that discussion, hopefully someone's going to tell me, well, a squared is a times a, and you're just multiplying that by a cubed, which is a times a times a. So there's a total of 5a, so it's got to be this one, right? We want to have that conversation. And then I want to add one more piece to it to really maybe help it hit home, because there's still going to be students that forget that. So any way I can present that multiple ways for students to get is super helpful. So by adding that slider now, I can quickly put in a bunch of different values and they can see which ones are equivalent. Because what we're saying is no matter what a is, a can be anything. It can be negative 3.3, negative 5.8, whatever we pick, right? Whatever we pick here, we can see which expressions are equivalent. So these three are equivalent no matter what. 8 is 6, not equivalent. Great. So love that too. Even just a quick review of, okay, a times a versus a plus a. One of those is a squared. One of those is 2a. Well, which one is which, right? And again, we can use that slider to match them up and see the equivalence and try to make sense of it that way. You could do this all the way up through trig identities, right? That's kind of the whole idea of trig identities. You're given the answer, right? So this idea of equivalence, I think really hits home. This idea of what a variable is, they start to understand that more. Sometimes that gets really, really lost. Those two things of equivalence and understanding a variable is representing any number. That gets lost when we have all these procedures and these steps that we throw at kids. And then the last thing I'll show is, we saw a little bit of this, that it won't do this on, it won't graph anything on your testing calculator, right? So I don't want this to be something that students are using as a crutch. I don't want this to be something where students are using this to replace the algebraic procedures, but I love it for feedback for students. Okay, so let me kind of set how I use this with my own students. So right now, maybe we're solving one variable inequalities, okay? Or it could be an equation, it could be quadratic equations and so on. Well, in the standard calculator here, won't do this in your testing calculator. In the standard one, it will graph the solution. So obviously I don't want my students to just go here, get the solution, write it down, be done. But I do want my students solving on paper, step by step, and maybe they get to the end and they realize their answer is wrong. They've checked the answer key, right? So I give them the answer key, they know it's wrong. But then what? They don't know what to do. Well, they can enter in step by step. Now they can come to Desmos, enter in step by step. Okay, so this is what I did the first step. I combined these two terms. All right, I did that correctly because I see the equivalence graphically. And I'm verifying the equivalence graphically. Again, that idea of equivalence, deeper understanding of that. And then we can keep going. So maybe we get something like this. And all of a sudden now we know, oh, this is where I made a mistake, right? So we're empowering the student to be able to find exactly where they made that mistake. And maybe now if they look closely, they can figure it out themselves, right? So it frees you up. You got 30 kids in your classroom, right? You can't find all their mistakes. It could be 30 different mistakes on this one problem. All right, so that empowers them a little bit more to keep going. And then also it might change how I present this to students. Maybe we haven't done any ones where we have had to divide by a negative yet. And maybe that's something they can discover on their own. So it's a lot more powerful. It's a lot more likely that they are going to remember because they see something visually and they discover it on their own instead of just, oh, Mr. Doyle told me to do this, so I'm going to do it every time I solve an inequality here. So they can see something's wrong, something's not matching up, and maybe even just on their own realize, hey, it's just flipped. It's got to be this. In order for it to match up, I've got to change that inequality. And so I think that's just a much more powerful way to present it, and allow them to really dig in and see it themselves of why that rule is what it is. All right, so I'm gonna stop there. Um, just kind of going through using the Desmos instructionally. Hopefully, this gives you some ideas of this is much more than just a handheld calculator, right? It's much more than just a calculator to do some calculations on problems that students are working. We can really get creative and thoughtful in how we present topics to students and allowing them to explore them, to do all these verbs, predicting, give their informal observations, notice patterns, build that structure, and really connect those representations. I'll check in with Beth real quick. Any questions that have popped up?
No, we're good, Nolan. Carry on, sir.
All right, awesome. So what we're going to do now is shift over to Desmos Classroom and run an activity a little bit, get you a feel for that. So you're really going to experience this from the student perspective, and I'll kind of model that teacher perspective a little bit as we go through. And then ultimately, a lot of the resources I leave you with will allow you to dig in a little bit deeper of step by step. Okay, how do I get this activity set up? How do I maybe edit the activity, create my own activities, and so on? But give you a little taste of, again, what it feels like to be a student and what it looks like in the classroom for your students and for the teacher. So in order to do this, I'm going to have you go to open up in another tab, student.desmos.com, and enter that class code, or the link that Beth will share in the chat will take you directly there and enter that class code in for you. If you have an account, you're welcome to sign in. If not, you can continue without signing in. That will work just fine for today. And I'm going to paste you to the first two screens. So the first screen that you're going to see just tells you the larger activity that the following three screens are taken from. So if you want to visit that later on in the future, you'll have that link for you. And then after that, I want you to just explore on screen two. You're gonna smash that try it button and then change some different things in the inequality. You can change the symbol, you can change the number, but just play around with screen two for the next couple minutes as you get into the activity. And if you're having trouble getting in, let us know. That's gonna keep an eye out on that Q&A there. And I'm gonna be kind of watching from my end. And if you're joining us from somewhere where you maybe can't open up another tab, maybe on your phone and listening, I'm going to go ahead in a second and just bring up the perspective of those that are logging in, the participants, and what they're seeing, and kind of play around so you can kind of watch from my end what my participants and my students for the afternoon are seeing as they play around with screen two. So there's a warm-up screen with Shear the sheep. She loves eating grass, does not like water. So I'm gonna hit that try it button and see what happens. And Shear is not happy to start. So we can keep going and see what happens after that. Maybe change 0, something else. And try a few more. Again, change the number. Change whatever you like, get creative. Just see what's going on with Shear. All right, maybe about 30 more seconds to play around. Seeing some interesting stuff, love it. All right, I'm going to pause your screen in 5, 4, 3, 2, 1. So you should no longer be able to navigate your screen. And I'd like you to bring your attention back to my screen that I'm sharing. And so I've got the teacher dashboard up right now. I can see everyone that's logged in over here. As we start to look at some of your responses, I'm going to go ahead and throw it into anonymized mode so no one knows whose response I'm actually using. And so these anonymous names are actually famous mathematicians. So I love that students will start like, well, who's this? And they'll Google it and they'll learn something about this mathematician and what they contributed. So that's kind of a neat little tool for them, as well as for me to be able to display student work and they feel safe, like not worried that their wrong answers or embarrassing answers will be up there. So I can see quickly who's on what screen. So some people never made it to screen 2 and interacted with it. And I can see that with my summary view. The teacher view is what I really want to get to. So on screen 2, I can see in real time what people are entering it in. Ooh, love this. Like, can we even get this up here? What heck happens when we do this? Oh my gosh. There's an arrow pointing to where that sheep is and it just stays in the water. I haven't seen that one yet. So love that. Right. And this is one thing I love about Desmos is it gives interpretive feedback. Oh, what's going to happen here? Oh, there's an error. Okay. So we have to do just one. All right. I even made a note of a few that I wanted to try while you guys were doing that I saw that would change because you were switching them. But if I hit student view, I can bring up what you all see as the students right now or what your students will see. And I'll say, you know what, an interesting one I saw was x equals 0. So even though it said inequality, what's going to happen maybe when we do x equals 0? Shear is going to drop and just sit still. Love it, right? So it's interpreting what the students are giving us mathematically. It's not evaluative feedback, right? It's not, hey, you're right, you're wrong. It's just like, here's what's going to happen, right? And so there's so much more power of what students can learn and how their thinking can be pushed forward by using that interpretive feedback. And a lot of activities are set up in Desmos that way. They're set up for students to explore on their own and try different things and be creative. So I was making a note as I was watching the teacher view of ones I liked. I also grabbed some snapshots. So what I can do is I can save, like if this is one I want to come back to and this one, I can save these to snapshots. And that last tab that I haven't looked at yet, they'll save them here for me to look at. So there were some interesting ones like less than 10.1. So I could present those in a slide, and I can also use it as a reference to go to that student's screen. All right, so 10.1, oh no. And when we do 10, I love that response because when we do x is less than 10, this really gets at that boundary, right? It's not exactly what we want. So when that happens, I love this. A student is probably going to want to say, you know what, it's got to be 10.1 to get that piece of grass, but 10.1's too much. Right? What a great conversation we can now have along the student response. Well, maybe let's get a little bit closer, right? Let's get a little bit closer. Still not going to work, right? So what we can do is hit that equal sign. And now we've got what we want. And if you notice, it just kind of made that symbol. If you weren't sure how I made it, I'm just going to hit backspace and it deletes it. I'm just hitting the equal sign after it. I'm typing equals from my keyboard and it's putting them together. You can also pull this up and get the symbol here. But I was just typing that from my keyboard. All right, so what I'm going to do now is let you go through the next couple screens of what the shear of the sheep looks like in the full activity, still not the entire activity, and just explore and see the types of screens that students will be interacting with and think about what the student's doing. And then the last few screens are marble slides. If you're not familiar with those, just explore a little bit and play around and see if you can see what's going on with those screens before I come back and kind of debrief these two activities with you. So at this point, we've looked at just kind of this introduction, this starter screen for Shear the Sheep. And I picked it in part because of that idea of allowing students to explore, to get that interpretive feedback and start to make connections. and then continue through the activity and see what benefits might come from the rest of it. So I'm going to kind of give you full rein, take away the pause and the pacing to just go through the rest of the activity over the next about 3 minutes. And then we'll come back together, like I said, and debrief.
Hey, Nolan, we do have a request before we leave today. If you could, in the calculator itself, if you could go over regression for us.
Absolutely. Go to that. And as you're going through these screens, like screen 4, you don't necessarily have to take your time to respond to all of that. You're welcome to, but you can also just kind of get a feel for, again, what the student perspective is, what types of questions, what benefit might be of having these screens, these 3 screens all within the same activity as students are working. Probably about 1 more minute to explore a little bit. You might not get through all of them. That's okay. See, some of you are getting to those marble slides, which I think are amazing. All right, I've seen a fair amount of you have gotten at least to the marble slides to explore a little bit. I'm not going to pause you this time, so if you want to keep exploring as you listen, that's fine. But if you come back to my screen, I'm just going to go through a couple things. I love, again, this second screen. We've already addressed this a little bit, but that edge case is just huge. The context is super helpful, I think, in this case of seeing that x greater than 3, right? We don't want to be right on that ledge. If we have that or equal to, then shear is going to fall into the water. And that context and that beautiful visual and animation is just a great anchor as we go later in the year. We can be like, okay, when you're talking about solutions, whether to include or not include, I can reference, remember when we did shear the sheep? Remember when we didn't want shear to fall into the water, or we wanted shear to get that last blade of grass? So it's that reference and that context that can be really, really powerful. And you see that with a lot of the Desmos activities, not just this one. In 4, there's a lot of screens within activities that are going to get students interpreting another student's response. Or there's a lot of debates, like one student said this, one student said that, who's right, who's wrong. And you can get some debate going and students having to justify strategies, justify solutions, going beyond, again, just the answer getting. The sketch tool is really powerful, right? So students can show their thinking to you. We want that to happen with the technology, where we see more of their thinking, not less. So you can think about that as the screen. You'll see screens like this a lot throughout Desmos activities. So shear the sheep is kind of more of a, you're developing that concept, introducing it, maybe not brand new, but you're developing that concept. And on marble slides would be more of a practice activity. So they know slope intercept form, and we want them to practice not with some boring worksheet, but like with a purpose. Like I want to be able to launch these marbles and drop them and collect all those stars. So how do I need to change this line? I need to change its slope. I need to change its y-intercept, right? And I can change so quickly and see what happens and as I change the equation. So those connections between the multiple representations. Success, right? Students are going to get excited. They're having fun. They're being challenged. Now they're going to have to create it from scratch, right? And then we even build up to restricting domains. So it's not that the line necessarily has to go through, or the graph of whatever it is has to go through all those stars. It's just we need those marbles to fall and hit all those stars. So the amount of practice they're getting in these is enormous, and they're having fun with it. And there's a purpose to it. And it's been really helpful for domain. Again, with that purpose of I only want this piece of the graph. So where do I need to stop my domain? Where do I need to restrict it? And kids really get into these marble slides. There's ones with parabolas. There's ones with exponential functions, the trig functions. You can make your own. So there's a lot of creativity that is brought out through this activity. All right, so really emphasize from there the student perspective of students being able to interact with the screen and what their learning experience might be. From the teacher perspective, the power of the dashboard is just huge. Those tools really align nice with the 5 practices, right? You can think about monitoring, selecting and sequencing which students' responses you want to go over, and making those connections with your students as you make those mathematics visible. So I just pulled like a few screens, and the content isn't really important, but I think the type of questions that are being asked to start with, inviting informal observations, a lot of different creativity, allowing students to be right and wrong in different and interesting ways with these questions. And then how I leverage the dashboard, the way it organizes student responses is really powerful. So, you know, this is something where students are typing in their answers. I can see everyone's answer. And so a lot of times I'll just throw this up and throw out questions like, who do you agree with? Who do you disagree with? Right? Or I might find the word it, right? Like what is it? So we can start analyzing student responses. Well, it is the vertex, right? So we can start to get more formal with our observations, right? Is there only one solution? Or we talk about repeated solutions, right? We can talk about the x-axis, things like that. So students are bringing their knowledge in wherever they're at. You're meeting them where they're at, and then you're lifting them all up together of where you want them to be. So differentiation at its finest. Another thing I like about the dashboard is this is where, again, the content isn't super important, but they had to enter in a range. And so what the dashboard's organizing here is it's showing all the students with their anonymous names that typed exactly this, all the students that typed exactly this and this and this. So again, I might even open who's right, who's wrong. I love that question when multiple ways are correct here, right? It might just be the simple idea of adding that set notation, but also the big idea of, oh, these are the same, right? And so that opens up a really good conversation. And this student is seeing their response, right? And wondering, hey, was I wrong? Right? No, it means the same thing. And it's so much more powerful when that comes up organically through the student responses instead of just the teacher saying, hey, we can write it this way or we can write it this way. Like that's just, you know, going right through our students' brains, right? But they're invested, they're seeing their responses up there. They want to know who's right, who's wrong. And you're seeing the multiple ways and the flexibility of how to write that. Sketching, you can see the individual sketches on the dashboard. And so you can start finding the interesting ones, maybe just a nice picture, but I also think this is interesting because it only touches once, right? So we might talk about x plus 8 is actually a factor twice, it's repeated, right? So we can start talking about that. We can start connecting it to the equation. But I started with a graph, which is a little more intuitive and easier for students to enter a problem with. This is interesting because it's upside down. And then we can talk about the equation, what has to be true in the equation to create that reflection, right? I can start to use the more formal vocabulary with my students. Also with sketches, instead of looking at them individually, I can do an overlay. So in this case, the students were plotting just a single point, and I can see all the students' points on one graph. And the darker areas are where more than one student responded. So most responses were right here. And then next, looks like there were multiple ones here and then some individual ones everywhere. And this is a really great example that follows this quote and how I look at the dashboard, that the student's wrong answer is most often the right answer to a different but related question. So when I look at this dashboard, I'm looking for those wrong answers and trying to ask myself, well, what question did this student actually answer? And what I'm going to do is, in this case, put it back on the entire class. I'm going to display this up there and say, you know what? Take this point down here and change the problem so that it's a correct answer. And so I'm going to push everyone's thinking a little bit forward on this problem, and they just have to switch one word. So in doing so, like I said, I'm getting the students to think more, everyone in the class. I'm also validating the thinking of the student who was wrong. Instead of just saying, oh, look, these students were right. Oh man, that student feels bad, they were wrong. There was some value in their answer, right? There was some good thinking going on there, and I'm able to celebrate that and validate it and help that student, push forward and not just shut down. Right, and then I might go to the other points and say, all right, great, everyone knew the perpendicular line had to have positive slope, but it needed to be the reciprocal. So which ones exactly go through that line with that exact opposite reciprocal slope? So when you're using those tools in the dashboard, ultimately it comes down to creating some discourse around student thinking. So how do I, put the student thinking on the stage under the bright lights and center my instruction around it? The dashboard really provides the tools to do that. And I get students talking about the mathematics and making connections and understanding it. With our limited time, we have just dipped our toe into the activities, and I really wanted to focus again on what it looks like. But as far as getting those activities and running those activities, you can find all of that at teacher.desmos.com. And if you go to, I'm going to pull up our agenda. Right, we talked about the calculator resources here and some of the links to the activity we used today, the teacher version, as well as the student link. A few places to go for some of the activities that you might want to use as you're starting to search. And then help.desmos.com, I highlighted that on the next page. So when you go to help.desmos.com, this is where I would start to continue your learning. So maybe you want to learn more about the graphing calculator, that's there. Classroom activities or building activities, right? You can go there and start to see all the different articles, or just do a general search as well of what you want to do. That's a great place to get started. As I mentioned before, there's professional development. So there are free webinars that are coming up, as well as recorded ones that are there for you to view for free. And the YouTube page has a bunch of videos. So not only those longer, like hour-long webinars, but they have quick video clips of like how to do this, how to do that. So those three resources should be really, really helpful to you as you continue your journey. And then I just put some links here to help more with the teaching and the dashboard, as well as some short videos of getting started with building activities. We do have a survey here for you to fill out as we come to an end here. So I kind of open it up to questions. I know I'm going to do the regression real quick as well before you go. But that survey is linked. If you don't mind taking some time to answer that, this is the bit.ly as well. It's super helpful for us as we continue to design and provide you all resources and support as you continue to use Desmos with your students. And so I think Beth's going to throw that in there, and I will run through. I still got like 1 minute to do the regression. And one thing I love about regression, there's actually a little tutorial. So when I go to the desmos.com graphing calculator, not the North Carolina version, this question mark, this help menu, has different tours here. And so I'm going to hit regression, and it's actually going to walk me through where it gives me some sample data that I can copy and paste right into my table. So you could create your own table, right? But you could also copy and paste data from a Google Doc or an Excel spreadsheet. And then I'm just going to, in the expression here, I'm going to, and this is how I teach, it's walking me through it right here with this little tour. But I teach my kids, okay, if we want it to be linear, just type your y equals mx plus b. But you need to change two things. You need to connect it, tell it to look at the table. So I'm just going to type a 1 after the y and a 1 after the x. I didn't do anything special to get the x1 and y1. So it's going to look at that table. And it's not going to be an exact equation. It's going to be an approximation. So we're going to do the little tilde right here. And so that gives me my line of best fit here, that regression. And if you wanted to use a different one, you could just change the format of what you type. So I know this is not an exponential fit, but if I do a, b to the x1, that could give me an exponential fit. You could do your quadratic and so on. That's a quick rundown of regression, and you can also go to that tabs now, right? help.desmos.com, always search regression, and it'll walk you through everything you need to know with a nice video and different steps down here as well.
All right, Nolan, we do have a couple more requests. I'm going to handle them in the order they were asked.
Sure.
So first one, I was wondering if there's a way, for example, in the calculator to type in 24 divided by x, and then to have Desmos create a list that would show x and y values.
Sure, so you could do that in the table. So let's see. Well, there's a couple ways I can do. That's a great question about converting to a table too. So we could say y equals 24 divided by x. So when I have that graphed, if I want to view the table of values, I can hit this edit list. This is just super, I'm glad this question came up. And when I do that, I get this option, this little icon to convert to table. And so it converts that to a table. It's going to default to these x values. If I keep hitting enter, I'll get more and more values. I can also come down, just arrow down to another row. I'm not doing anything special to add another row. I just arrow down, or you can click below the previous one, and you could put in, any number you want here. And then it's going to give you that y value.
Awesome. All right, next question, matrices.
So there is a matrix calculator that's separate from the graphing calculator. So if you go to Math Tools, right, we've got the graphing scientific for function. There is a matrix calculator that you can play around with there. And again, the help.desmos.com, you could search for matrix calculator and get a little more support as you explore using that.
All right, I think we got them all. I'm double checking real quick. That's it, I think. I'm gonna grab the screen from you, sir.
Okay.
And close us out. So we want to thank you for your time. We know we are a few minutes over, but we did want to address those questions while we had you. I'm going to send out an email with these, with our email addresses for follow-up. I'm here to help you with any questions related to North Carolina or our testing program. Nolan is a great resource if you have questions about the power of Desmos. Just as a quick reminder, anyone who registered will receive a follow-up email that will be late today, and it will come, the sender will be North Carolina Public Schools, and it will have the recording, and it will have all of the links. And with that, we thank you for your time. Nolan, thank you for another amazing presentation today. And we will conclude now. Thanks so much, everyone.
Thank you all.